Dear students, today we are going to see about basic computer organization and design. And the first one is register. And the list of registers for the basic computer is data register, address register, accumulator, instruction register, program counter, temporary register, input register, output register. And the number of bits for DR is 16-bit length. Address register is 20-bit. Accumulator is 16-bit. Instruction register is 16-bit. Program counter is 12-bit. And temporary register is 16-bit. Input register is 8-bit. And output register is also 8-bit. And this data register is used to hold the memory operand. AR is an address register which holds the address of the memory. An accumulator is a processor register. An instruction register holds the instruction code. And program counter is holding the address of the next instruction. Temporary register for storing the temporary data, and input and output register for input character and output character. And this is all and this is the diagram of basic register and memory. The next one is the common bus system. So here the connection is, so bus is a path through which the data will be transferred. So here the first one is the memory unit, and second one is address register and program counter. Third one is, so seventh the number is, and these are all the registers connected one below one. And here is one of the multiplexer, and through which the bus is connected, the common bus system, and the multiplexer is connected through is connected with this common bus. And this multiplexer will select any one of the register, and through which the data will be transferred or into the register. Okay, so here the bus multiplexer is S1, S0, S1, S2. And this is a 3-bit multiplexer, so 3 cross output is 8. So 8 register will be selected based on the input. So suppose the input is 1, 1, 1, it is 7. So then this memory will be selected. So once it is selected, either the write operations or read operations will be performed. So write is the data is transferred from the bus to the memory, and read is the data will be transferred from memory to the bus or to the some other unit which is connected to the which is connected with the memory. And suppose if it is this multiplexer is 1, so then automatically the address register will be selected. So each register is also connected with 3 inputs. One is load and increment and clear. So load means the data coming through this bus line is entered into this AR, that is through the load input. Increment, so this register content will automate. So here AR is an address, so the address will be incremented by 1. Clear means you want to clear the register, you can clear. So each register is connected with a common clock. So all registers are connected with a common clock cycle. So here is the clock. And another one is so likewise all the registers are connected with this common bus. And here is an accumulator. So this accumulator is actually the output is so 1, 2, 3, 4. So 0, 1, 1. When you give an input like this, so immediately the accumulator will be selected. Accumulator is for processor, just like a processor. So here is also there are 3 inputs: load, clear, and increment. And this is connected with an adder logic circuit. So this is accumulator is added with one another register, and the result is also stored in the accumulator. And if it is any carry is generated while adding, that carry will be loaded into E. So normally, and the data is coming from data register. So here is the connection. So one data must be come from this data register. Another is available in the accumulator, and this is connected with the, so the accumulator, and this is, so accumulator is connected to the, so here one is, another thing is here, this is the data, okay, load data. So this is connected with this one. So either the addition is performed with data register and accumulator, or the processing process will be performed from the input register. Direct data is coming from the keyboard and added the content with accumulator, and again the result is stored in the accumulator. So this is the way the system will work. So this is called a common bus system, and this is the explanations given in this slide. And this instruction format is what is meant by instruction format? An instruction which contains one opcode and address and one index mode register. One mode is 1 bit, an opcode and address. So this may be the operand. So where the operand is stored is based on the addressing mode. So this is the instruction format. So normally on computer instructions, what is computer instruction? You see here, and this is the format of computer instruction. Normally format, and this is the memory reference instruction. Computer instructions format is categorized into 3 types. One is memory reference, another one is a register reference, another one is input output reference. Memory reference, so the opcode is 000 to 110, because this is opcode is totally in this basic computer organization, and this is each instruction's address is actually the 16-bit address. Accumulator is 16-bit, AR is 16-bit. So normally address is 16-bit. So 16-bit is divided into 3. One is 0 to 11 is an address, 12 to 14 is opcode, and 15 is a mode address. This mode is if it is 1, and this is called a indirect mode. So if it is 0, it is a direct mode. Okay, and this opcode is 3-bit. So 3-bit is 8 instructions, and this address is actually the 12-bit address. So number of data we can store in this address is 2 power 12. So 4096 locations there. So where we can load that many data. Okay, this is memory reference. That is the opcode is varying from 000 to 110. And register address mode is this one is 0, I is 0, and this is 1 is 11. And this is running from 111. So this in this input output, this is 1 and this is 11. Okay, and we can write any opcoders like this. So here is the memory reference instructions means, and this is 0, and this opcode is running from 00 to 110, and this is the 4-bit address. 3 into 4, 12-bit actually. So you see here, so this may be memory reference, either it may be 0 or it may be 1. Okay, or it may be 1. Either it may be 0 or it may be 1, whatever it is. Okay, and if it is 0 means and this is the format, and if it is 1 means this is a 1 in the sense what? 1000, it is 8, and then 1001, it is 9. So this up to, if it is 0, this is running from 0 to 6, and if it is 1, it is running from A to F, and the remaining 3 is an address bit. Okay, and this is register reference, and this must be 0 and this must be 1111, and this is varying from what? 12 bit, and the first bit again 0 1, the second bit is 1, third bit 1. So this can be 7, 7. This is always 7. This is always 7, 800, 400, 200, and so on. Okay. So likewise IO instructions. IO instructions what? And this should be 1, and this is 111. So always this is F. So F is varying from what? So 800. So first this is 1. Okay. So 800, 400, 200, and then 0. This may be 8. 80, 40, 20, then 8421, and so on. And next, the instructions may be divided into arithmetic, shift, logical, and more. Program counter, IO instructions. Okay.